Example 3. So my apologies. It looks like I forgot this example at the end of the last video. So let's put it in here into a new video. The quality control manager of a Taco Bell restaurant wants to analyze the length of time that a car spends at the drive-through window waiting for an order. It is determined that the mean time spent at the window is 59.3 seconds, with a standard deviation of 13.1 seconds. The distribution is skewed right. Okay, well, we need it to be normal. It is currently skewed right. Letter A, to obtain probabilities regarding a sample mean using the normal model, what sample size is required? We need a sample size greater than or equal to 30. Okay, so if we're going to work with this, we need to have a sample size greater than or equal to 30. Letter B. The quality control manager wishes to use a new delivery system designed to get cars through the drive-through faster. A random sample of 40 cars. Well, we're good. That's greater than or equal to 30. So we can now obtain probabilities using the normal model. We have a large enough sample size, reflects the central limit theorem. A random sample of 40 cars results in a sample mean time spent at the window of 56.8 seconds. What is the probability of obtaining a sample mean of 56.8 seconds or less, knowing the population mean is 59.3 seconds? Do you think the new system is effective? Okay, mu sub x bar is equal to mu sub x, is equal to mu, the population mean, which is 59.3. Sigma sub x bar is equal to the population standard deviation divided by the square root of the sample size, which is 13.1 seconds from the original paragraph, write-up here, the original piece, divided by the square root of the sample size. The sample size is 40. Into a calculator, I went out to 3 decimal places. There we have it. Okay, what is the probability of obtaining a sample mean of 56.8 seconds or less? So less than or equal to 56.8. And let's go to our normal calculator to come up with that. Okay, back to here. Okay, stat calculator is normal. And get into there. Our mean is 59.3. Our standard deviation is 2.071 to 3 decimal places. And we want the probability to be less than or equal to 56.8. Compute 0.1137. How about that? 0.1137 is the probability. Let me put this back and you can see what's the probability. Well, this is less than 56.8. And the probability is that shaded region right there. The 0.01137 is the area of that region. So we'll come to here and we'll write that down. Always like to put a 0 in front. At least I try to anyways. 1137. Okay, do you think the new system is effective? Is this unusual? Okay. Is this unusual? Well, 0.1137 is greater than 0.05, so this can be expected, okay? Wishes to use a new system. Is it effective? Well, what happened was not unusual, so it's kind of questionable if it's effective or not. So, not unusual. Right? It's not unusual. This is usual. If it's not unusual, it is usual. So that's to be expected. So we would say that the new system is not effective. It's not unusual. That's usual. Therefore, the new system is not necessarily effective. Okay, letter C is our final part of this question. Treat the next 50 cars that arrive as a simple random sample. There is a 15% chance the mean will be at or below how many seconds? So we're going to use our normal calculator in a slightly different way. Okay, letter C. We know that our mu sub x is the same. It is 59.3. Okay, we know that we have 50 cars here as our new sample. So our sigma sub x is equal to sigma, the population standard deviation, by the square root of the sample size, 13.1 divided by the square root of 50, and we come up to 3 decimal places with a calculator, 1.853. And here's what we're asking. There is a 15% chance, so we're given the probability, and we're trying to figure out the number, at or below. So this is asking this, the probability x bar is at or below some number, and that's going to be equal to 0.15. That's our question. We know the proportion is 0.15. We want to know what is the chance the mean will be at or below how many seconds to get that proportion. Okay, there's a 15% chance that the probability will be at or below what number? Okay, so we can use our normal calculator to do this for us, and it's kind of funky. Let's go, I shouldn't say it's kind of funky, just you can compute either one of these two things. So let's put in our mean, let's leave our mean, 59.3. We have a new standard deviation because our sample size changed, 1.853. In this case, we don't know what we're looking for, but we do know the probability. So we can put in 0.15, and we can now press compute, and we need 57.4 seconds right there. It computed it for us. Our variable is less than, the probability that it's less than or equal to 57.4 seconds right there. So you can compute either. Kind of nice to know that. So we'll go back to here. And so this is, let me go back to the question. There's a 15% chance that the mean will be at or below how many seconds? Okay, the mean will be at or below 57.4 seconds. And that solves that one for us.